Hello and welcome to Learn Synthesis with Pure Data, Season 2, Episode 2. In this episode, we're going to build on the patch we made last time, which was a looping sampler. You can record your voice in, and it'll just loop whatever it gets recorded in. You could also record other sound in. It was a mono audio looper, basically. And we're going to build on it so that we could start granulating the sound. We'll also look at making this into a fully functional, abstraction. So it could be used with other things, because over the course of this series 2, we're going to make some other things, some effects and different things where we can kind of combine these different modules together, mix and match them, and use them in different ways. So anyway, here we go. Okay, so here we are. This is a folder where I'm keeping the patch that we made. And as you see, I renamed it. I renamed it to granulator _ mono. And then I put a little tilde at the end of that file name. The tilde is a key that you can find, to the left of your number strip on your computer. Most keyboards are standard in US English. You use the shift key and you can get that tilde. Now, there's a reason for that. As you know, in PD, there's a lot of objects that we make that have tildes on them, and that designates them as an audio object. It's kind of like a symbol to say sound goes through this. Now, I'm going to right-click on this because I also have PD Lork installed, and they both open PD patches. I just want to make sure I'm opening this with regular Pure Data. Okay, so here we go. Let me just see if I can arrange the screen in an appropriate way here. Put this right here. Now, what I'm going to do is, first thing before we start granulating, I'm going to make this into an abstraction, or basically a patch that can be used as an abstraction. And a way of doing that is going to arrange things a little bit here just so we have good spacing. First thing you want to do is we have some graphic user interface objects here that we want to be able to see and interact with. I'm just selecting them all and moving them over a little bit here because we're going to do something called graphing on parent. That's where you right-click on the background somewhere, and this is called the background canvas. You go to Properties, and you see Graph on Parent as an option. Below that, there's an option for hide, basically to hide the name of this object name, it says there. But in this case, it would be the name of this patch, which is granulator _ mono tilde. Do we want that appearing later? I'm going to leave that in, but we're going to check this off and hide that eventually. But I want you to see what it is. Now, let's see. We're going to hit the apply button, not OK, but apply. And you see a red square has appeared. This is the area that will be graphing on the parent, meaning when we load this patch into something else, this is what's visible and what is almost like the window that you can operate this patch with. So we want to basically fit this around the outside of the view here. So one thing, the way you do that is here, the size indicators for X and Y. That's like the horizontal and vertical size. X is horizontal, Y is vertical. And then you have a margin setting. It's saying 100 by 100. That means where in relationship to the topmost left-hand corner is this. It's 100 pixels in horizontally and 100 pixels down vertically. That's what that means. We could try to fit within that, but actually let's make the margin a little bit less. All that really matters here is we set the margin and the size in such a way that all the things that we want to see come through. Okay, so that's 50 by 50. Good, we can start fitting in up there. Now, what do we have here? This is like 140, I think, tall. I forget what the sizes we set last time. No, I think it was 175. Plus maybe a little 10 space here, 185. These are like 50, 235. Let's try 250 for vertical size. That's the Y. And hit apply so you can see. Okay. Just to give ourselves a little bit of room, let's make it 275. We'll have a little extra space, but we might need it. And then the width. I think this table here is 350 wide. So something like 375 just might do that. All right, it looks like we'll be able to fit this in. I'm going to hit OK. And then what I'm going to do is drag around to select all these objects. And let's try and fit them in here a little bit more neatly. Okay, we got a little extra space at the bottom. Go to properties again and just say, 265 sounds about right. Now this is stuff that can be changed later as we build and work on this more. Okay, now we did that. Now what I'm going to do is save this, and then we'll see what an abstraction actually is. Control S to save, Command S in Mac. Close this. Now let's open up the folder where this is. And we're going to make a new file here. So I'm going to run PD separately. Pure data, not per data. It's another flavor of PD. I'm going to go to the file menu and say new. And then I'm going to take this new file and give it a place. Give it a home first. File, save as. This is where I'm keeping them. Might want to have your own PD folder on your computer for these things, and then different subfolders for the things you make. I have them for this overall course. And I'm going to call this modules. Because over time, we're going to add more and more modules to this as we make them. Modules, and that's it. Save. Now, let's make this bigger. And you always want to do this when you're doing abstractions. Know where they're located and where the file you're bringing them into is located. Modules is right next to granulator underscore mono. So that is where we're going to put it. Now, when you type an object, it first looks for, is this an object name that's part of PD's language? Like we've been making objects, tab read, ADC tilde for the analog to digital converter, DAC tilde. It looks through that stuff first. Then it looks in its extra folder, its externals folder, wherever that is set up to be on your computer, and sees if it's an external that it can put in. If it's none of those, it's going to look here. Actually, it may look here before externals. I'm not sure of the order, but it definitely looks for object names first. This is named granulator underscore mono tilde. Boom. Everything that we graphed on parent then becomes part of this object. And remember that option we saw on graph on parent where you could hide the name? Yeah, that's the name there. And it's called granulator underscore mono tilde. So we want to open this up, and we're going to take that out. Go to properties. Notice when you open up the abstraction, just like with subpatches, it grays it out while it's open. When we close this window, we'll be able to see the abstraction again. But we want to check this to hide the object name. Press OK. And the shortcut is Control W or Command W for closing the window. There we go. Now it hid that name. It doesn't look as cluttered. Now, when you're doing abstractions like this, since we'd like to use this as a module that will connect up to other things, we want to put an inlet on it and an outlet on it to connect up to other things. So we're going to open it again. One inlet that would be good to have is an inlet for audio signal to come in. Now, we already have here in our recording subpatch. Now, notice these are subpatches. You could graph these on parent if you have things in them that you want to be visible. But there's a difference between subpatches and abstractions. Subpatches don't utilize the $0 that abstractions do. And that I'm going to explain in just a minute. It's an important thing to know. So we go here to open recording. Here's where our ADC comes in. We'll allow this overall module, this abstraction, to allow audio to come in from the outside. But it'll need to get here eventually because this is where it goes into write SF to record. So I'm going to call this $0. No, we're going to receive with an R. $0 underscore audio underscore in. And then we can move this over a little bit so it's not too cluttered. So this is a receive. To receive from where? The inlet that we're going to make here. I'm going to move these a little bit down. I like things to look nice and neat. So we can create an inlet here to receive something into this abstraction. And it's just like having an inlet or an outlet on an object, basically. So we type inlet, and we got to type tilde, because this is bringing in audio signal. And our inlet tilde is going to then send what it's receiving to that receive we just made. So we need to make a send. $0 underscore audio underscore in. Remember, in these names, you don't want spaces. They are case sensitive, so that's why I always type them lowercase. So right now, I'm going to hit Control W. And here's our modules file that's graphing on parent. And you see now we have an inlet on it. We created an inlet, so it gave it one. And so we can create an ADC tilde object here. Take the left side or channel 1 and hook it up there. There we go. Now we're going to right click on this, go to open. And I want to explain a little something. You can have multiple inlets. They can be tilde inlets, meaning receiving audio, or they could be non-tilde inlets, in which case they receive non-audio data. So the way it knows which inlet is left to right. So if I make another inlet here, since there's only 2 inlets on it, it'll actually automatically put it here on the right corner. Now if I make a third inlet left to right, we'll have 3 spaced evenly across. And it'll continue to space them evenly across. But they will correspond left to right with the inlets that you make left to right in here. We're not going to make any more inlets right now, but I wanted to explain that. But now we need to make our outlet. So we're eventually going to make a send for this. Receive R $0 underscore audio underscore out. And then I'm going to hit Control 1 right away. And it puts and hooks up nice and neatly for me an object so I can type outlet tilde. So now this will send audio out, but we got to give it the audio to go out. So in our playback subpatch here, we want to send our audio output to $0 audio out. So we could actually just take over this object, change it from a DAC to a send. Oh, you know what I haven't been doing with these sends? I need to put a tilde behind them. So S tilde, because it's audio signal, $0. We're probably got error messages in our PD window. We'll look at that in a moment. But anyway, remember this is supposed to be $0 underscore audio underscore out. So I need to add tildes to my sends and receives. Yeah, look at these error messages here. Every time you make something, it's like, wait a minute, this can't handle audio output. There's no tilde on it. That's why you got to watch the whole video, man. I make some mistakes now and then that I fix later. So that send and receive combination are tildes. Now we need to fix this one. This send and receive need to have tildes on them. And here's where it goes to audio input here. So we need to put a tilde behind that R. And then we're going to do what we're supposed to do, test this out. After you make a few things, decide to do something, debug it right then and there. Like in other words, test it out, make sure it works. So we close that. We're now back at modules with this abstraction in. And I hit Control S every step of the way, because when this is open, we're saving to the file modules.pd. When we open the abstraction, and we press save here, we're saving to this file, which is granulator underscore mono tilde. You see what I mean? And if you try to close PD and you haven't saved one or the other of those, it does warn you and ask you if you want to save. But I always like to just save every now and then as I go, just to be safe. Now, just so we hear this on both sides, we're going to connect this to both sides. As it indicates, this is mono. We record in one waveform, and that's it. Now, this does have a load bang in it that we made last time to basically, what do you call it? To turn on DSP right away and send some other defaults. Let's test this recording out. Let's test this recording out.
Let's test this recording out. Let's test this recording out.
Let's test this recording out. Let's test. Very good. It works. Now, here's where the magic happens. And now this is what I'm going to explain $0 and the whole beauty of it. I'm going to go into edit mode here, create an object, and type once again. Oh, I made a number box too. What the heck? Okay. Notice how instead of like with subpatches, you type PD space and then the subpatch name. You don't do that with abstractions because they're different. We're going to load the same one. Granulator underscore mono tilde. Now, if we were to be naming these things like the table and all our buttons, they're sends and receives, without using $0, bringing this in, I would have gotten, these are error messages from before. I would have gotten a lot of error messages. Most of it saying name already in use or duplicate table name, stuff like that. Like your playback toggles here are named, its send name, if I didn't have the $0 on it, would be play send. And the signal from this one would be going to things over here. Signal from this one would be going to things over here. They'd be sharing all these names, and PD wouldn't know one from the other. You get a lot of errors, and pretty much things wouldn't work. But you see how it says here $0 underscore waveform. And it also says $0 underscore waveform here. Internally, PD has, in its own mind, replaced those with numbers. Something like 103, maybe this is 104. It makes them automatically. And so, according to PD, all the $0 names in here are different than all the $0 names in here. So that way you don't have to worry when you're loading these different abstractions into your parent patches. You don't have to worry about names getting confused with one another and creating problems because they all technically have different names to PD. So here we're going to record into this one. Hello, let's see. What? Something happened there. Something not right. Maybe I do have something that's labeled wrong. Hello, are you on? Well, I also don't have the ADC going to it, so we're recording nothing, basically. Now here, my microphone is plugged into input 1 on my interface, so I need to use that same input to go over here. Over here, this output is going to left, this was going to right, or 1 and 2 out on the interface, so I'll hear these different things on different sides. How about this? This is what's going on the left side. This is what's going on the right side. And so let's play them back. This is what's going on the right side. This is what's going on the left side. This is what's going on the right 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 side. This is what's going on the left side. All right, there we go. So yeah, we'll be using this modules patch in the future to put some of our different creations in and hook them up. Like we're going to be making a delay, so we'll have a delay effect that we can pass things through. All sorts of things in this series that we'll then be able to kind of mix and match and drop them in and out. So that's why I like to do things the way I do it. Always have that $0 there in case whatever you're making is going to be combined with other things. Even if I was making a different thing, like a delay effect, it'll have an audio input, and its send for that audio input needs to have a $0 on it. So because it may conflict with other names and stuff that I use. So in order to get rid of conflicts, basically I do that. Okay, but what we can do now, we just saved modules, but we can open up, although one thing you see here, they're both sharing the same temp name. That's something that can easily be fixed. Oh, it opened up in PDLork. Never mind. Let me just do this. Open with pure data. That's something we can fix, believe it or not. Because each abstraction, since it gets its own unique number, each time we use PD Granulator, it'll record its unique number if you use it as part of its name. So we're going into the recording subpatch, and we're going to put this as part of its file name. Because we could even have 3, 4, 5 of these in there, it makes no sense to depending on what you're doing, it's up to you, but at least for me, I like to be able to drop these in and not have file name conflicts. See how this is sending a symbol of $0_waveform for this message so that it writes to the proper table. If we do the same thing with the file name, will be okay. And this is how we're going to do it, because now we're sending this message. Remember, with message boxes, they'll take a variable like a $1, but they don't take a variable like a $0. So you got to use the symbol boxes to send them in. All right. So what I am going to do, because I want these both to be sent close to the same time, I'm going to make another symbol, $0 recording.wav. That's the file name. Okay, and I'm going to flip-flop them here so that they line up, because technically, in order in this message, it's the file name before the table name. But now what we're going to be doing is we're going to be sending two variables. $1, $2. And in order for this to work out right, we need to send them as a single message, which is called a packed message. Pack, and then it's good practice to indicate what type of thing you're sending. We're sending symbols, so we use the abbreviation S. And that gives us two inlets here, where these two symbols can be sent in to this message. And they'll be taken in at the same time. Now, the thing is, we also want to send these at the same time. The way pack works is you could send something into the right inlet, or you can even have more inlets, like if you put SSSSS or SF or SFB or all the different like abbreviations for the types of things that Pure Data sends. It doesn't get sent until the left one comes in. That kind of like pushes everything through. But we really want to make sure this gets in there and then this goes. So we're going to make a trigger, bang, bang. And remember, the rightmost one will happen first. Okay, V instead of B. All right, there we go. So this will get sent first. It gets stored in pack. This gets sent next, just milliseconds later. And then it goes ahead. And all this is coming from a delay object that is just delaying the bang to make sure it happens after everything is properly stopped. So we're just using bangs here to trigger these things to happen. So now let's see here. Close this, and I'm going to record the file. Actually, you know what would be cool? Let's save this, close it. We're going to open modules. And then we'll see what numbers behind the scenes Pure Data is giving things. Oh, this opened in PD Lorc again. It actually wouldn't be a problem, but since I'm doing this course in just regular PD, I might as well just use regular PD. Okay. So here's our same patch as before. This recording goes on the left side. This recording goes on the right side. Now we still left our original recording.wav file there. And looks like it's still there. Wait a second here. Oh, we got error messages. Something's wrong. Sound filer. Read. Oh! Oh, of course. Let's close this. Go back to our granulator. Ow! I keep doing that. I'm so used to double clicking. Oh, man. Open with. I'm using one for one class, one for the other. So I'll always be opening one. Now, here's the thing. Recording. Where are you? Right here. That's not the only place we need to change things. Remember, this is saving things from, this is loading things from file. We didn't record it to that file name. We recorded it to open recording.wav. And so what we need to do is this. Let's move this down so it doesn't get cluttered. Now remember, in here, we can't use a $0 in a message. It'd be nice. It's just one of those things that, no, it doesn't do that. So we have to use a symbol box to send it in. $1, because it does read that. But there's only one thing we have to tell it. We have to tell it this. Recording.wav. All right, so I'm just going to select this, hit Control D to duplicate, and it pops it right on top. You got to make sure you grab it while it's blue. All righty. The whole idea is we need to write it to the correct file name first before we can open it. But since this whole abstraction is going to have its own unique $0, it'll work until it doesn't, you know. There's always a surprise. I just opened it in Lork again. What the heck? Trying to close you. Okay, so we open modules. We got rid of our other recordings there. It makes it, oh, I just did Lork again. It makes it each time you record. We could add the functionality of being able to open files and save the files of different names and stuff like that later. Not in this episode. We have a couple steps that we're going to do in this episode to get ready for granulation. And then next time we're going to add windows for this. Because this episode, you know, I think we're reaching the halfway point basically. So we're going to record to the left side. And we're going to record to the right side. And we can play them back. So we're going to record to the left side. And we're going to record to the right side.
And we're going to record to the right
to the
side.
left side.
And we're going to record to the right side. And we're going to record to the right side.
All right. But when you start mixing those things around, then it gets much more interesting. Now, let's see on file what happened here. There's the hidden numbers, the magic numbers that $0 got replaced with. 104 and 105. Let's see, was it the right side that got to be 105 or was it 104? And we're going to record to the right side. Okay. So we're going to record to the left side. So basically what happens underneath it all is PD replaced $0 in its own internal memory. You don't see this unless you do something like I did. We played all the $zeros here are really 104. All the $zeros here are really 105. And that's how she goes, folks. There, you now know the mystic. You know the natural mystic of abstractions. What we're going to do now is just expand on this. There's a few things we're going to do this week, and next week is when this will really start sounding like true granular synthesis. I'm going to open granular mono, and I did it in Lork. The thing is, it will work fine in Lork. It's just, you know, we're just not using that in this class. Like things made in PD vanilla can function in PD Lork. But things in PD Lork, if you're using some of its special graphics and stuff, won't work in PD vanilla. I was just seeing if I could get rid of the scroll bar. Oh well, never mind. Okay, so now granulation, and this has to do with playback, a little bit of calculations and stuff. Let me open this. Here's our playback engine as we left it last time. Now, what granulation is going to be is basically you have an audio stream here and all the audio samples. Granulation chops it up into bytes or slices called grains, where basically you could take maybe 100 samples here, 100 samples there, 100 samples there, and then shoot them out in different bursts and do different things with them. So what we need to do is make a cutting mechanism that allows us also, well, it's not really a cutting mechanism, something that allows us to play it back in chunks. And what we're going to do is select all this, move it over to the left, giving me a little bit more space here on the right. Alrighty. I'll make sure I'm all on screen here for our home viewing audience. Okay, and I'm going to get you out of here. There we go. All right, so a good way for this to be done is using a sample and hold mechanism. Now, we have a phaser over here that we're using for playback. And we have an ability to change its speed, which is right here, playback speed, as it cycles through the waveform. We're going to make another phaser that allows us to do a similar thing over here. Phasor tilde. Now, it's going to have the ability to send it a speed, and I'm going to put a number box above it because in this case, I'd like to be able to see it. And I think over here, let's add a number box here so we can see it over here. We're going to just have the number box display what comes out of playback speed here. Now notice I'm hooking this into the left inlet of float there, not the right inlet. Okay, it's easy to kind of misread which inlets things are going into. Alrighty, okay. Meow, meow, meow. I'll move you up just to get you in line there. So this is also going to receive playback speed because we're going to keep these things for now in relationship with one another. In fact, I'm going to set this up exactly the same. Like I have over here. I'm just going to select these. Now when you hit that Control D or Command D in Mac, make sure you grab blue selection. If you click somewhere else or you miss all this stuff that I just duplicated, would be sitting on top of that. But this is duplicate, Control D or Command D in Mac. All right, there we go. So we basically just wanted the same stuff. Let me see here. We're going to add to these triggers here because we could use these same triggers to do this. This does, we have how many triggers here? 3. One to turn on sound. We're going to keep that. Actually, we're not getting rid of any, but we'll use the same one for both. And then like both of these phasers. And then we have a 0 going into phasers. Phase, and then we have a bang hitting the float box here. Those we need to duplicate. So we're going to add 2 more bangs. And I'm going to rewire these. So I'm deleting these because it'll visually look better if they're done in order. First, the one message gets sent to turn on sound. Then we give phaser its phase of 0 to make sure it always starts at the beginning. And then we give this float its bang to make sure that the playback speed sitting in here gets shot out. And then we have the same type of thing over here, except we need to make a 0 message. Make a message box with a 0 in it. And that's going to be sent out. And then we're going to bang the float box over here so that that happens. Okay, now, is this where I want it? Let's keep things pretty much horizontally or vertically aligned here. All right. Okie dokie. The starting mechanism's in. Now the stopping mechanism. And here we just have a trigger bang bang. One to turn off sound and the other to turn off the phaser so it's not running anymore. So we're just going to add an extra B to here. And we're going to make the rightmost outlet go to the sound turning on, turning off. We'll make the middle one go here. And we need a message over here. Now this message, as on the other side, is actually hooked up to the number box below the float box. I'm just lining them up to be, just looks nicer if they're kind of like in line with one another. There, and then we need to make sure we hook up the bang to it. There we go. So these things are going to start and stop at the same time, and they're going to use the same playback speed, at least for now. Here, just to make it look more like the other side, put that there. Okay, now what this one's doing is it gets multiplied by, because phaser goes 0 to 1, it gets multiplied by sample length, which is the length in samples of the recording that was recorded in. This is not going to go full length. This is going to go the length of the chunks that we're calling them. that we're dividing this up into. And we're going to call those grains in our naming system here. Remember, these are just names, but we got to use that $0 underscore, and we're going to call this grain length. Yeah, it'd be nice if we made it something like a receive. Put the R first. All right. And this one's going to have its own multiplier over here. Star tilde, because Phaser does output things at the audio rate, at the sampling rate. So it's an audio device, audio object. Now, I know we haven't made grain length yet, but we will. But I'm just trying to line these up with the other side so you could see how this is doing a similar thing to what our playback mechanism is already doing. The thing is here, it's going to, instead of go from 0 to the full length of the sample length, the full length of the recording, this is going to go from 0 to the length of the grain that we're cutting things up into. Now. What do we do next? We are going to use samp hold, I believe. Samp hold tilde. Now, this is an interesting object. You could be sending things to it at the sampling rate, and we're going to actually be sending it. We're actually going to disconnect this here. Until it goes to tab read, it's reading our waveform. It's really just sending out numbers 0 to whatever the length of the waveform is. That's what this is doing, and then it goes back to 0 for the loop. We're going to put that in this side. What samp hold does is things that go into its right inlet get held there and aren't outputted until it receives a 1 message. Or, excuse me, I think it's a 0 message. It's either 1 or 0 here. Let me go to the help file. See if I can get it real quick here. I'm just looking for 0 sample signal. No, wait, the right inlet. Right inlet here. Control signal. Like it uses 1s and 0s. It's almost like the 1 to kind of like send out the sample, 0 to... I think the thing is you send it a 1. That means, all right, select that sample that is currently in it. Like here's a stream of numbers going from 0 to however hundreds of thousands of samples. And that number gets stored here. And then basically when it reaches 1, it like says, okay, that's our sample. As soon as it receives a 0 through this inlet here, then, and actually what I saw from that help file was the opposite. I apologize, folks. Whatever samples it's receiving through its left inlet, when this 0 or 1 happens, like the 1 says, okay, use this sample. As soon as it gets a 0 here, it shoots it out. Okay? And what we're going to do is then take the bottom of Phaser that's going from 0 to 1. Now, this is before it gets multiplied. So this is going from 0 to 1. Out here, it's going from 0 to the length of the grain. But here it's going 0 to 1. So when it hits that 1, whatever sample this is at, as soon as the 0 comes out, it comes out of here. And then what we're going to do is add it to this. Now, just to kind of make some sense of this, I'm going to set the rest up, and then we'll look at it in more detail, just to understand that concept of what samp hold is actually doing. This goes into tab read, because the number coming out of this adder, we did a plus tilde here. What comes out of this adder, that's the sample we want read from the table. Not just the steady stream from over here, but the chunking that we get, or the granulating that we get from here. That's the sample we want read. That sample gets read. The amplitude value of that sample comes out and gets played, and that is, digitized sound. Okay? Alrighty, so now we have this thing called grain length, and we gotta define what that is. And we will do that now. And we're going to put that in here under our calculations. Now, you see under our calculations, we have a bunch of things that do get calculated. All this was explained in episode 1. Well, basically, after this thing gets made, like after you make a recording, things come out like normal speed. Basically things like that get calculated, and that speed can then be changed later by the functions that we have over here. And we could do similar functions to change other things, but that we're making now. But basically, after the recording's done, that's when we get our sample length. And then our sample length is something that we're going to use to calculate here. So sample length comes out. Every time after recording, sample length happens, and that's when we get to recalculate some things. So the sample length, the length of the whole file, comes out. Now, another variable we're going to put in this thing is something called grain freq, meaning frequency. Receive $0 grain freq, F-R-E-Q. Now, we haven't made that yet. And we're going to now. Let's make that first. Remember, all this is to make our grain length. But we're going to make that by going into our loading subpatch here. Because these are things that get defined as soon as the patch opens. And we're going to have a grain freq definition right from the start, because we need one from the start. It can change later. Okay, it can change later. And we can make mechanisms to change it, but we need something to start with. So now that we added another bang here to bang out a value for grain freq, I'm just going to switch all these so that, yes, DSP happens first, because these things happen right to left. We need our sampling rate calculated next. Basically just reads what the sampling rate is. And look, we're at 44,100 for some reason. Although last time I was using 48,000. And everything still works. Why? Because I have sampling rate as part of the calculations of all these numbers. So if for some reason another sampling rate is what you're operating at, you're okay. And this 0 is just to give a beginning and initial speed value for our speed slider that allows us to change the speed of playback. Next, we're going to put this. We're going to put a message box with 100 in it. And then we're going to call that grain freak. So this is where we make the send. $0 underscore grain freak. FREQ. Okay, so we have one to start with. Now, let me just use this table as an example just to say, what this is for. I think we can still record at this point. Not everything is finished that it'll function properly yet, but hello, hello, hello. Hello? Stuff happening? Well, I think I need to close and reopen. But let's just imagine we had a waveform in here. Basically, what our initial last week mechanism was phasor treating this is 0 to 1 times sample length, which is all the way out here. So that goes through this table. That gets sent to tab read, so it reads where the dots are, where the samples are in the waveform, and puts that out to the DAC so we hear it as sound. Now what we're doing is we're cutting it up into segments, and these segments will be called grain freak. Because if I say 100, I'm basically saying I want 100 grains per second. 100 slices of the waveform per second. So how do we calculate that or use that? Well, let's go back to calculations here. If we have our grain freak and divide our sample length by it, for example, we just make a thing there, a divider. Now, grain freak will be set at the beginning, but we want the ability to change it later as part of some of the effects we want to do. So we're going to put on it a trigger, bang, float. Because the way any math object works, like a divider, whatever comes in through the right inlet, in this case, the float from grain freak, float meaning a number, the number goes in here, and the sample length gets divided by that number. But it doesn't get calculated unless this number comes in to calculate it. Or you send a bang into the left inlet. And so this way, anytime sample length changes, we record again, this gets calculated. But we also want it calculated anytime grain freak changes. We haven't set up a method for changing it yet, but we will in time. $0, and this is going to be what's called grain length. Okay, so grain freak is saying how many times per second, or how many slices per second, how many grains per second are we going to have? And the grain length is going to be calculated saying, based on what the length of this thing is, if you divide that by 100, actually, divide the sample rate by 100, you moron. Yeah. Let's change that. Yeah, it's not the sample length divided by... It's sample rate. Okay. So never mind that sample length, because we're talking about grains per second. So sample rate. So the sample rate gets divided, and let's say it's 100. That's its default. So if we're at a sampling rate 44,100, divide by 100, we get 441. That would be the length in samples of our grains. Okay. So now where are we playing with this? In playback. So now we have our grain length. We have our playback speed. The playback speed to start would still be the same right now because we want this to go and operate at the same rate as this. So that basically, as I said I was going to explain, the way this is set up is it's going to play the first grain going from 0 to 441, since my sampling rate is 441. All the calculations are in place for it to be other sampling rates. When it gets to 441, the grain starts over. This half starts over at 0. But the samp hold mechanism pumps out the number 441 here. So then this is 441 plus, oh, wait a minute. Where's the plus? Yeah, this is the plus. So 441 gets shot out here, and then that 441 gets added to 0 through another 441. So it's basically adding up 441 to 882. So when these are in sync and running, at the same time, we're basically going from 0 to our full sample length, no problem. Okay? So that's how that's kind of set up. But we do have speed controls, and what we'll be adding next week are windows so that we can hear these grains more individually. Although this week, after we test this out, we're at the debugging stage now, we are going to play with it a little bit. So let me close this. I saved it, and now I want to reopen it because now that I made those changes, that load bang stuff, we want to make sure that goes through. Open with, yeah, now I remember, PD. Okay, get that out of the way. Now, I'm going to debug it, see if we can record. Can we record, please? No. Do we see any reason why here? Why is recording not working? I know why. Yes. Let's just put a quick ADC in here. I'm not going to keep it here, but while we're building this, let's put a quick ADC right here. So that way we get our audio input. Remember, we moved all that to the outside. And if we don't have modules there, that file open with the ADC and the DAC, we're not going to get sound in or out. Okay, this is just going to go to one side, but that's all right for testing it out. Okay, now can we work? All right, we're not getting playback. Now, this is the stuff we kind of changed. So that's to be somewhat expected because it could have been typos or mistakes put in here. Okay, so here, when the one gets selected, these bangs go off. Sound gets turned on here, and that's where you want it turned on. And the turn off is the same connection. Let's go here. We have our phase being sent. Then we have our playback speed being sent. Over here, our playback speed is the same. It's being sent. And I'm just going to lift you up. You are in the left inlet as you're supposed to be, but the bang also puts that through. Now here, we got a 0. All right, so what I'm going to do is run this again. For playback, and look at the numbers here. All right, that's gone into phaser. You know what I think it might be? I think my initial thoughts were correct. I heard a little snap there. So yeah, there's a little bit of sound happening here. Phaser goes into this side. You go into this side. Let's see. Okay, I'm going to pause the video so that I don't take too much time away in doing this. Okay, folks, I figured it out, but I didn't do any changes yet except for this. I'm going to make these changes so you can follow along with me. Yeah, the leftmost phaser for the granulation goes into the right inlet of sample hold. And this phaser that was playing back our whole table from last time goes to the left inlet of sample hold. And it is samp hold. You know, that's how PD spells it. So there's no LE there. And that goes to the right inlet of the adder. That's all fine. This is what needs to be changed. I was having this thing play back at the same speed as this, and it can't because it's the same, it's a different length. So this is something called playback speed. What I'm going to do for now, because we want to be able to make this different later, is I'm just going to name this grain speed. Okay? And then here we still have grain length. That actually is going to be trying to remember what we called it. We'll call it grain size. Okay, this is the speed at which phaser goes from 0 to the size of the grain. Okay, now we need to change some things elsewhere. Get you out of here. Under load, loading. This thing that we made here, where I'm just banging out the number 100, that's still fine. But this is going to be grain size. Okay, so it has an initial value. So that's what need to be sent out there, grain size, to go directly to that phaser's multiplier to say what the length of the grain is. We're just going to call it grain size. I guess I could say grain length, whatever, but I've already changed it so it's grain size. And now under our calculations, this should be the last thing we have to change. We just need to change names here. Yes, it's sample rate divided by grain size. And that gives us our grain speed. Okay, there we go. Close that. Now, since we've changed some of the names, we need to load from the beginning again. Come on. Okay, we turned it off. Save it. Let's open it from the beginning again. And then we should be good. Because I opened it on its own, it's giving me yet another recording there. I should, after making these fixes, just run things from modules and take out the ADC and the DAC in here. Oh, all right, here we go. Open with PD. All right. Let's see if we're lucky this time. Let's see if we're lucky this time. All right. Let's see if we're lucky this time. Let's see if we're lucky this time. Let's see if you're saying, well, you just achieved the same thing you had last week. And that's true, but we've added infrastructure that will allow us to do some things. Of course, we can slow things down, speed things up, all that bit. But let's look at some of the values here, for example. Yeah, because I made the, what is it called? The grain size 100. Our grain speed is the sampling rate divided by 100. So we could, let's try if we change this a little bit to 400. Let's see if we're lucky this time. Let's see if we're lucky this time. Let's see if we're lucky this time. Get a bit of a distortion there. Let's see if we're lucky this time. 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 Now, next week or the next episode, we're going to get rid of that distortion that we're hearing, but we're going to still maintain some of the effect that we were hearing there. Some of that change of the timbre of the voice. And we're going to do that by putting windows on the grains. And that is what makes the granular synthesis as smooth as it normally would sound. Now, I didn't want to do this week because that would just add too much time to this. But what I want you to do to make sure we stay on track here, we'll edit from within modules from here on out so that we can keep this modular in its format. Get rid of the ADC and the DAC, save it like this, and we'll be able to do the edits next week straight from the modules file. Alrighty. So that's basically it. We got it together because then we're going to be able to use our speed, our playback speed, and our grain speed as two different parameters that will allow us to get some pretty interesting effects. And then since we'll be adding windows next time, we'll also be able to add window size as another thing. But thank you for joining me. I hope you learned a bunch. And any questions, please let me know. Drop a comment or whatever, and see if I can help you out once I get my brain oiled. All right, folks, stay free and take care.